Okay, great. The audio is working. That's good. Great. The audio out just wasn't working on my other device. Hello. Should we get some better light? Oh, this is fun. All right, so we think this is working. It's not amazing. Cool though. Nope. Let's see, how is the talking versus typing loudly, which is the other thing I will do, because that's supposed to be the whole point of having an external mic in my book. Cool. Okay, let's get started. So I'm not going to use recordings. I'm doing this for real. Okay, great. Thanks so much for whoever is there. It's really helpful for me to just know that, well, to be able to imagine that people are there at least, because I have trouble rubber ducking, right? I have trouble really imagining that I'm communicating with somebody. It's even better when I can like hear the gasps of, amazement, if possible. But okay, this is real low, right? Oh, okay, it's not plugged in. Okay, cool. All right, pumped. Okay, so let's talk about methods in Python, right? So we've got Python here. And say we were looking at, this will be great, I'll have different autocomplete, so I'll type things manually. Okay, so methods and functions in Python, right? So we've got functions, they look like this. And we've got methods. And I have a class called bar, and then stick the exact same thing in here. Now it's called a method, right? And the big difference between functions and methods in Python, right, is that if I call a function, I have to provide all three arguments, every one of the arguments that I specified, for each parameter in the definition, I need to provide an argument. But for a method, when I create an instance of the class and then call the method on it, I only have to provide two of those arguments. So I'm going to write 2, 3 here to show that it's the first one that's missing, right? You can even see that in the bpython highlighting here, right? And if I don't do that, if I try to provide another, I'm going to get a weird error message that is frankly kind of misleading, but we'll talk about later. Okay, right? So functions, methods, that's the difference here. But it's kind of interesting that I want to say we don't really have methods, or syntactically we don't have methods. It looks like maybe this is behaving differently, right, because it's inside of a class. But if we back up and we make our class really simple instead, so now, right, there's no, it's an empty class, there's nothing in there, and then we just slap on a function, foo equals foo. We don't have to call it the same thing. We could call it, bar.hello equals foo. And then we look at hello. Well, if we create an instance, bar hello, right, that now gets called with just two arguments. So it's a method. Okay, so I want to say that syntactically there aren't methods in Python. It's just the matter of it being on the class that makes a function a method. All right, first comments check. Thanks, Kay Allen. Oh, go Tom. Thanks. Great. Okay, so that's great. Well, I don't know. That's great. That's unusual. That's confusing, right? I mean, how is this getting turned into a method? I think ought to be the question we should ask here. At this point, behavior could be kind of like JavaScript, I guess. So nothing we've seen here is different from the way that JavaScript works. Let's bring up some JavaScript. If we look at, we call it temp.js. Once that comes up, notes, pres, methods. What am I looking at? So you don't need to know much JavaScript for this, but these first, and we're not synced, so never mind. Oh, it's called test.js. But these first couple lines in JavaScript are the way that we write a class. So that, I know it might not look like a class, but that's a class. And down here is a method. And whether it behaves like a method in JavaScript is going to mean what is this bound to? So here's a difference between Python and JavaScript. In Python, if we're being good, right, and we're writing our methods, we're going to call them, we're going to they're going to look like this, except they're not going to look like that, right? Because we're going to come back here and follow pep8 and rename this first one self. And then we can do whatever we want in body there. And in JavaScript, we don't have to do that. We just have this implicit self. It's called this. And we can tell if something's behaving like a method because this will point to the object here. So it so happens that this code here works, b.foo, but if we take the method off of the object to which it belongs and put it in this stored thing, now it doesn't work. But in Python, it does. If we have that instance here, and I say stored equals bar.foo, stored is going to work just fine. And by work, I mean we only have to provide those 2 arguments. It has a reference to self already, right? So stored 1, 2, it works just fine. If we try to call it with that 3rd argument, it's not going to work. Okay, so this is not having the JavaScript way. And if you missed all that, don't worry about it. It's not. JavaScript is a pretty weird way to do it. So there's something else going on here. Well, I guess something else, another way that this could work, this being how does this function, which seems to be just a function, get turned into a method? Well, first let's look at it. So if we look at bar.foo here is still a function. It says function bar.foo, so the name has changed a little bit, but it hasn't changed, actually. It was the original name because we defined this one inside there. If we go back up, we could change that, say foo equals foo. Okay, so now we're down here, bar.foo. It's just called foo still. So it's just a function. And yet, when we look it up on an instance, somehow now it's a method, right? I hope that's true. Did we mess that up? Yep, that works, and this doesn't. It's like, nope, that's too many arguments. This is supposed to be a method. Okay. Well, another way that this could work is that when we create the instance, maybe maybe when we create the instance, we copy over all those functions and then turn them into methods then, right? So that's possible, I guess, but we should be able to call it's called vars on B. Now, vars is a Python function that gives you the corresponding namespace to an object. And it says, well, there's nothing on there. And if we look at, just to see how vars works, if we look at bar, indeed, we do see, well, along with a lot of other stuff, we do see a, there it is, this foo here, right? So, how could we disprove this one? Well, if we already created our B here, right? And then we went and added another function to it. So def another func of whatever, xy, keep not doing anything. So we're telling whether they work or not by whether they get an error, right? And then I just slap that on bar.another func equals another func. I didn't have to call it the same thing, another func. B has that somehow. So it's still looking it up on the class. But for some reason, now it just takes 1 argument. It's a method. Okay, so none of those. So let's look at this object. So if we have an instance and we look at that foo thing, it's not a function anymore, right? So normal foo is a function, but b.foo, when we look for that object on the instance, that is a bound method. So it's a new kind of thing. So that's the thing I was saying, maybe it doesn't really exist before. Well, it doesn't exist at, say, in the syntax. It doesn't exist when you're defining the class or the functions, but once you access it, it does. And right, it's going to have that right behavior. Well, foo isn't, but whoops, my fault. Foo isn't, but if we get our instance b.foo, that is that method. We can take it off. We can store it somewhere. Stored, it's still that method. So before we go on and explain how this is working, I want to take a moment to appreciate how great it is that we have automatic method binding in Python. So if we go back to JavaScript for a second, we'll have to navigate back to that directory. It's annoying. If we go back to JavaScript for a second, we'll see that the way we have to get around this, because when you pluck a method off of an object, it's not bound to that instance that you got it from anymore. So we have these workarounds. So because this works, but this doesn't work, if you want to be able to take it off, you have to do something like this. We have to say, well, okay, we've got the object. Let's reference that method, and then let's call bind on it and explicitly bind it to B. And then this works as we expected. Or let's write our own little closure here. So this is a new function. It's like a Lambda function that takes no arguments and just calls that function. So this stuff's kind of annoying. Or maybe we'd have to like take it past the arguments with those star args. Doesn't do anything in JavaScript, but take those arguments and pass them in, which would be a hassle to have to write all that. So it's pretty cool, yeah. That in here we just get the stored method. Here's some times when it's useful in Python. So say you've got a dictionary here. I'll have a dict where A can be 10 and B is 2. And I want to get the sorted, I have the keys of that, maybe a list of keys so we can see it. Great. Store that somewhere. Stuff, list of keys. And I want to sort this by the corresponding values in that dictionary, right? So I want to say, look at sorted D, or sorted stuff, so those keys. And I want to sort by the value that I get by looking them up in the dictionary. Well, there's a method on the dictionary called get that does that. And if we didn't have this binding, then this would get passed through as just a function, and it wouldn't be associated with that dictionary anymore. But because d.get, this just works fine. If we do that in 2 steps, I'll call it the getter equals stuff.get, and now I can say, whoops, it was d.get, and now I can say sorted of stuff. And let's use key equals d.get, which we've now called getter, which I just split into 2 lines to see that, wow, it really is nice that we get automatic binding. Another case is in if we're threading, right? Threading.thread target. We're going to do something like d.get, or probably something more complicated, but we can reference that method directly without having to go write a closure around it. Or if we were in Java, right, we'd have to write a little anonymous class that acts as its own closure. Anyway, so real convenient. Great. Okay, we know it's convenient, but how in the world is this working, right? How are we taking an ordinary method or an ordinary function and somehow on lookup turning it into a method? Okay, so let's get our simple example again. And so somehow, when we get this, it's a method. Well, okay. So it turns out that attribute lookup in Python is not quite as simple as we probably hoped, or as we probably imagined, right? We're probably thinking, okay, attribute lookup, I would imagine what it does is maybe it first looks at, so if I say b.x here, first I'm assuming we're going to look at, let's make it an example with a few more things. X equals 10, def bar, that was fine. And then I'm going to make an instance of it. I'm going to put some attributes on it. Hello can be on there. 1, 2, 3, 4. Great. So if I say b dot something, I'm imagining that first it's going to look at the vars of b. It's going to say, great, what's stored on b, the actual instance? Oh, just hello. Okay, I was looking for something. Next, we might check the vars of b's class. And that is a bunch of stuff, right? But definitely in there is this x being 10 and bar being that function object. And if we don't find it there, we might go to the parent class of bar if it inherited from something and on up, right? And that's mostly true, but there's a special case where there are a few special cases. The one we'll look at is that if the object we find has a special method called get, or dunderget, then instead of returning the object itself, it returns something else. Let's take a look at this. So if we were to, if we have a thing, let's call it thing, which has a method called get, take some args, who knows what they are, return 17. And then we go back to our good old bar method. And I guess we were doing foos, weren't we? Foo, and then def. Got all this stuff. Great. We also, let's put a thing on there. I'm going to say t equals thing. We make one of these. If we look up bar, we'll get that method as expected. If we look up something like x equals 10, we'll get that as expected. Oops, x equals 10. We'll get 10 as expected. But if we look at f.t, we're not going to get this thing object. It's actually going to run this code. Okay. So we actually run this code, end up getting 17. Wow. If there are objects which have get methods, then the thing we get back might not be the thing we actually found on the object. Okay. So where this is going is that turns out all along, right, functions just had one of these. So foo.get is a thing. It's a method wrapper, as a matter of fact. So it's something that turns this into a method. Okay. Wow. So in Python, we kind of have these functions that are just functions, but then if you look them up on a class, you get some special behavior where what you get back is not necessarily what you put there. So let's look at the full. This is called the descriptor protocol. Let's look at a more complete example. So I believe the signature here is going to say, I'm going to have to look it up because it's either owner instance or instance owner. I bet it's instance owner. Instance owner. And we'll test that by printing instance and owner. Oops. We're in Python 3. Return 1. Class. Oops. So if we go get that thing, which is itself a descriptor, looks like the first thing we get is the foo object, great, and then we get the class. So this is correct, in fact. So here we get to choose what we return based on who was asking for it. So in this case, I'm going to say, well, we're going to try to imitate a function here. So what a function does is if it's being called by on an instance, it has one behavior, which is returning a, so we'll put all this in an if. Let's see what instance and owner are when we look this up in the class. Class foo t equals thing. Foo.t looks like none is that first argument when we look it up straight on the class. So I'm just going to say if instance, meaning this is being looked up on an instance, then let's return, we'll start easy, let's return 10, else return 20, 320, sure. So this is something that behaves a little bit like a method because it returns different things, or like a function, really. F.t is going to be 320, but but if we get an instance of it, that is going to be 10. Different behavior, great. The next thing to do is to build a method. Well, how do we go about that? So, that method error we were seeing before. So class foo, right, def bar. I said we'd talk about later. This is what we get when we try to call it with 3 arguments, even though it had already used x. This bar takes 3 positional arguments, but 4 were given. I've seen that before. I recognize it from another use. We say import, see how about from functools, import partial. So there's this idea of partial application in Python and lots of languages. And that is that if you have a function, which here we just have foo again, but we'll do something with it. Just print each of the arguments. if you want to take this function and build a new version of it where you only have to use some of the arguments, we can say new func equals, new func equals partial of foo, and I want 1 to be, 17 is going to be the value of a in all future calls of this new func function. And now I can say new func, and now the signature just takes 2 things. So 1, 2, great. And when I run this, 17 is the first one, and then 1, and then 2. So I've created a new version of this function, new func, that takes 2 arguments instead. So this should be familiar. This is kind of how methods work. And similarly, if I try to pass 3 arguments, I'll get the same annoying message that says foo takes 3. So first of all, we're still calling it foo, even though I just ran new func. And we're saying it takes 3 positional arguments, but 4 were given. So this should be real familiar. When we partially apply a function and then use the wrong number of arguments, the error message references the original function. Now this is a bit of a leap, but I'm claiming based on this same error message that methods are implemented in a pretty similar way. So we could just use this partial thing. So if our goal was to make a method up here, which that was thing, I'll start calling it, well, yeah, thing's fine, def get if instance. So if this is looked up at an instance, then let's return the, oh, well, we're going to need a function here if our goal is to methodize something. But we'll return the partialed version. Otherwise, let's just return the function itself. Okay. Now we will need to call this methodizing function. Def init with, oh my, pass in the function, self.func equals func, and then our get, we'll say if we're looking this methodizing function up on an instance, then let's return the func, the partial of the function with the first argument being the instance. Otherwise, let's just return the function. Now, if I were to write a function and I were to write a class, I'll call it methodizing function, and I've forgotten some things. I need to say from functools import partial. Okay, class bar def we're going to say the methodizing function of foo, and the goal is that this is something that should behave the same as a function. So if we say bar.foo, we should get the original function, but if we say b equals bar, we get that partial version, and hopefully the way that partial version works is that, yep, it just takes 2 arguments. So our repr function doesn't quite match, but we've made a method. So I claim this is the way that methods kind of work, because if you look at a function, it just has a get method that does exactly this. Now the code isn't written in Python, but it's following the same descriptor protocol. And it's kind of neat that this is how we do methods, because it's a sort of general pattern where whenever we want a new behavior, so we want a class method or we want a static method, or then we just provide a new wrapper via a decorator around the function, and the way that it's retrieved is different. So for example, if we have a class method BC, the way this thing is going to work, if we just print class BC, if we look for it, if we try to call it here, now it's already gotten the partial version of this. If we look at it, it says this is a bound method. Whoop, my fault. So okay, we saw that one. It worked. Then I hit the wrong key. Let's look at the other one. If we have a static method, so that doesn't take a class. A, B, C. So if we look up foo on bar, we just get the function back as normal. But this time, if we create an instance of bar and we look up foo there, we also just get the function back, right? So the static method must have its own get that says, you know what, regardless, just return the function. Okay, so I think this is where I'm evaluate the time. Okay, so if I'm 30 minutes in, that's plenty of content. I'll be smoother and I'm going to record these screencasts ahead of time. But I want to tell you the rest of the story, which is that, so that's very cool. And that's the way that Python does object orientation, basically, right? Otherwise, we just have like structs with, dynamically resizing structs of functions, and it'd just be namespacing. But we get that object orientation by customizing that lookup behavior. But this doesn't answer the question of, do we really have to use self for everything? Which we didn't even address. But if you look at a class in Python, if we're following the rules, suggestions, there's an awful lot of writing self, right? You might write something like this, then you might have to refer to it here. And something that's come up, especially when Python 3 was a new thing, was, should we get rid of self? Should we not have to write this all the time? Especially now in Java, say you don't even have to write self here because it's compiled and it'll figure out, B, you must mean the class member B, not a local variable B. We can't really tell the difference very well in Python, so we probably couldn't do that, but at least could we get rid of that self, right? Could we just say foo of, you know what, it's just a common case. Just figure out what method you're inside of. And I think the symmetry of all that a method is a function that happens to be inside of a class is kind of neat. But then you talk to someone more used to a compiled language, or a statically typed language, and they'll like those limitations. But a method is a different thing. I think it's neat that they share the same behavior, that it can be implemented the same. I think I'm not going to include any of this rant in the real thing. We're just going to end on descriptors, really cool, super powerful. And maybe write our own. Okay, phew. I think that's, I'm gonna call that good. Now I have recordings of these different parts, but I'm gonna really appreciate having the recordings that I just came up with, so I can figure out where to swap in new content. For the real talk, I'm hoping not to live code at all. I'm also hoping to have some slides and just really have focused code at all. No ranting at all? Yeah, we'll see. Maybe tomorrow at the practice one that I give at work, I might. But I really like to have I'd like to have the PyCon version very focused and very focused and without philosophizing that's not useful, I guess. I'd like to avoid analogies. I'd like to avoid giving information that's derogatory. I don't want to be derogatory about JavaScript or something like that. And I don't want to bring up self unless it's something people have themselves thought about and I have a good argument. One rant part is that one way you could implement classes, or another way, methods, I mean, is that you could maybe inspect the body of the function, and if you see the word self in there, then you know that it's going to be a method, and you give it different behavior. And self is a keyword, and we saw self there, so we'll have to know that this needs to be a method. It can only be run in the context of when it was looked up on something else, and that thing assumes that value, kind of like JavaScript. Class could be similar. It's not great maybe to have to inspect an entire method to find out whether it's a class method or an instance method or a static method, but we do that with generators, right? Yield, you have to look through the whole function, you find yield, and you say, oh, now I know that this function works totally differently. So I could see that, but it's nice that this is so extensible, right? It's like, yes, a static method and the class method and an instance method are core parts of the language, but you could invent your own kind of method and integrate it with all the others really well. So that seems like a neat, but I don't want to say it's like beauty for beauty's sake. I would like hopefully it's that's useful. I'm a little thrown off because I was just talking to a coworker who was coming from more static languages and was like, "Oh, property is kind of a hack." So there's another one. Property is this implemented via descriptors, or the descriptor protocol at least. And he was saying like it seemed like it's a bit of a hack because there isn't really language support for it. It wasn't there from the beginning. And I wanted to say, no, Python just has a smaller base, and we build these object orientation features on top of that. Um, but I'm not sure how I feel about that. Like, yes, you can have a more integrated system if you know exactly the features you're going to want forever, and you just build them in at the core. Um, then that would work pretty well. Okay, I'm going to stop though. Thank you very much for everybody that was contributing to this little number here, because that's what helped me. Makes it more stressful, but also enabled me to have more empathy for a listener thinking about this. Great. I'm going to sign. Well, actually, no, I'm just going to hang out. But if anyone has a question or a Python thing, happy to talk about it. So I've got my little fancy BPython REPL up. Or if you have any suggestions or thoughts on methods in particular, or questions, ideal would be like, Tom, I didn't understand that. Or Tom, what about like a function that works this way or that way? Or cool. Thank you very much. Yes, look forward to it at Python at PyCon. It's going to be so much more polished and focused. Focus is the important part, I think. And fortunately, I'm at the stage now where there's too much content, and I'm crushing it down. Anyway, thanks all. I'm waving to say goodbye, but I'm also going to keep streaming for a little bit and then maybe I'll philosophize about streaming. Streaming, huh? I like YouTube videos. YouTube, kind of a weird thing. Over the last couple months, not a couple months, but especially before that, while I was interviewing and kind of in this vagrant state, I watched a fair bit of YouTube, which I consider kind of trash compared to other media I could consume. Like much better to watch a movie, much better to read a book or play a video game or something than kind of the stream of YouTube videos. But it is interesting that you can kind of see inside people's lives and talk to them, blah, blah, blah. I think that's kind of interesting. Tasks for myself. What I'm going to do tonight is chart up what I was getting to in each of the sections that I went through today, because I think I was able to have more empathy and remind myself of what someone might care about at that moment. Not change the structure of the talk, but add in a few tidbits, and then come up with a table of contents for the talk, or like an outline of it, and base the slides around that, because I think people really I like to kind of tell a story, but it is really nice when you outline, here are the things we're going to cover. I think the core focus of this talk is how does a function get turned into a method in Python, or what are methods in Python? I think I shouldn't mention the self stuff, even though I wrote a lot of content about that. I think it doesn't come in as well. Okay, so I'm going to watch this video and see what I went into, and then change. And I'll probably re-record some of the screencasted versions. Right, right now I have recordings of each of those parts that I live coded. I'll finish those. When I give the talk tomorrow, I think I will mostly live code it, but only if I'm smooth enough to cover those points in the 25 minutes given. I think I will be. But then that means changing it quite a bit for PyCon, because I don't want to be live coding there, and I don't want to just be like flipping through. They should be really tightly focused, I guess. It's just too easy to have a presenter looking up at the screen. When I say a presenter, I mean me. It's too easy for me to just look up at the screen and watch things be typed. And if you can bring the audience in as this shared sense of exploration and experimentation, I think that's great. But it's hard when you're not really live coding to do that. But also, live coding kind of sucks for when most of us do it for an audience. So I'm grappling with that. There might be little sessions with some live coding, but probably it'll be carefully focused, recorded sections. Askinema is a great tool for recording little terminal sessions. And I think that's it. Okay, thanks a bunch for people for listening. I'm also maybe streaming a thing this weekend, which will be a much longer extended. The other talk I'm giving at PyCon with my friend Rose, we are talking about sockets and networking, and that will be really exciting. That ought to be live coded, but it's also a 3-hour workshop. We are going to try out mostly the passing, making sure we're both speaking, because we both have a lot to say about this topic. We've both outlined what we want to say, but just practicing the logistics of it should be good. Also, yeah, I'm starting to understand why, a frustrating thing that in the context of video games is where I've heard this. But like, if you want some information and it's in text on the internet, great. You want to know how to beat this one boss, great. You open this big text document, you control F, you find it. And then in a YouTube video, you just have to there'll be a tiny piece of information, like the release date of something, and you have to watch a 10-minute video to find it. And that's just such a pain. But I'm starting to understand how it's just kind of fun to talk. And when there's no one else talking back, because you're alone in a room, you can just talk a bunch. And I can understand sometimes why someone might want to listen to it. So I guess I'm sympathetic, but it's a weird world. Okay, thanks a lot turning this off. Also understanding why people do this. Live coding, fluent and useful, encourage you to consider concrete. Yes, and absolutely. Okay, that's huge. I have to know foobar. That was a rule. There is not going to be any foobar in the real thing. Yeah, I've been blocked on that for a couple days, and when I give it at work, there will be foobar, but there can't be foobar in the real thing. That's just not okay. Also, there can't be animals for subclassing. You can't use shapes for, yeah. Um, yes, I was blocked on this last night, and so I just went with foobar for this live coding, but I promise not to say foo or bar in the real talk. I will have a concrete example, and it will not be I mean, database would be fine. Hopefully it's not a database related example. I don't like, well, that's fine. I can whine about that. Yeah, thank you. That's the main focus. So I'm going to tweak what I type in places, but I have to re-record these because um, it can't be foo and bar. That's the most, yes. Okay, thank you, KLN. Great reminder. All right, I'm going to sign off and focus on that. All right, thanks all.